Hello, my name is Arosh Segar, and this my student details are provided over here, and my supervisor is Mr. Prasan Yapa. So the title of my research is Enhancing Communication for the Hearing Impaired, a vision-based system for translating Sri Lankan Sign Language with emotional expression. So moving on to the agenda, so this is what we'll be covering for this presentation. And next is the problem definition. So the main problem with the existing Sri Lankan Sign Language to speech or even text systems in Sri Lanka is that it doesn't, most of the systems or even all of the systems don't consider about the emotion conveyed through the face. So that is not incorporated into the existing systems. So this is not only for the Sri Lankan context, but also around the world. And another problem is that another reason that Sri Lankan Sign Language systems are required is because there are lack of Sri Lankan Sign Language interpreters in Sri Lanka because around Sri Lanka there are only about 100, no, sorry, around 8 to 11 interpreters. And another main reason is that communication barrier for the hearing impaired people has become a really big problem, and not everyone understands sign language for them to communicate. So even in emergency situations, it's really hard for these people to communicate with others to get help. And a lot of studies have mentioned that emotional depth in communication is a key factor in understanding the sign language. So these are some of the main problems with these systems. And some of the findings through the key literature review were some of the systems use sensor-based approaches, but this is not very feasible because this is very expensive and it's not easy to carry around. So you need physical IoT devices for it to work, and it's computational heavy. And another key point that was mentioned is that emotions are missing from outputs, and most of the Sri Lankan Sign Language systems focus on gesture recognition. It ignores emotional expressiveness. And also, vision-based approaches are more practical and cost-effective than sensor-based ones. And also, facial expressions are critical for conveying emotion and also grammar in the sign language. So these were some of the key literature findings that were discovered through the key literature review. And moving on to the research gap. So after the literature review, some of the gaps that were identified were uh, no facial expressions are incorporated into the Sri Lankan Sign Language speech systems that are already existing. And also, the systems that already exist, the speech that is conveyed or output, it sounds more like a robot. It doesn't sound natural. And also complexities in dynamic Sri Lankan Sign Language. So the largest available Sri Lankan Sign Language is SSL 400, which is a dynamic dataset, and not many researchers have done uh, researchers to identify dynamic sign language. They have only done static. So dynamic is basically a video dataset. So it should also identify the temporal uh, features to understand the whole sign that is being signed by the interpreter or even the hearing impaired people. And also lack of systems integrating emotional expressions into Sri Lankan Sign Language speech translation. And existing Sri Lankan Sign Language systems rarely provide a full sentence, so they only identify single words or even single sign languages. So those were some of the research gaps that were identified. And the main objective of this research is to build a real-time vision-based mobile system that can translate Sri Lankan Sign Language gestures and incorporate the emotion identified through the facial expressions into expressive speech. And if we were to look at the project pipeline, so uh, this is actually developed using Flutter so that it is it can be used by through web, mobile phone, and also uh, the input would be basically a video file of the sign language. And then once you select the sign language from your mobile or any device that you're using the app from, the next step would be to click translate on the mobile phone or even the device that you're using it from. And then a backend process, it will call an API for the video will be processed in the backend. So that is done through an API. So the video file is transferred to the backend, and the processing involves three different steps. So gesture recognition, sorry. So gesture recognition, so that is done via a visual transformer called transformer and a media pipe. And also emotion detection is done via deep face, and then speech synthesis is done by uh, typecast API. So previously I used Parler TTS, but I found a better solution called typecast, which is uh, more quicker and more natural than it sounds more natural than Parler TTS. And yeah, after the emotion and also the gesture is recognized, those two will be input into the speech synthesis module, which will convert it into an emotional speech. So that will be the output of this whole application. So if we were to look at this in a diagram view, this is how it would look like. So the input would be video capture, and through the video we'll be identifying the emotion and also the sign language. And then the two will be input into the text to emotional speech generator. So that will output the speech with emotion. So next is the implementation pipeline of this is an in-depth diagram of how the system actually works. So the diagram presents an end-to-end architecture for an automated multimodal sign language translation system with emotion-aware speech synthesis. So the pipeline begins with video input of a sign language user, where each input frame is resized for processing. This the system splits into two main modules. So mainly a sign language detection module and face emotion detection module. So in the sign language detection module, f- uh, it detects the hand and the pose landmarks using MediaPipe. The landmark data are processed through an embedding network, and temporal features are extracted by a transformer encoder. Sorry, transformer transform encoder. An attention-based fusion layer combines these features, which are then decoded through a sequence model for final sign language recognition. And the next module is the face emotion detection module, which extracts facial features with deep face, and then uses a convolutional neural network ensemble to predict frame level emotion probabilities. Applies and it applies temporal smoothing to infer the user's dominant emotion throughout the video. And those two are input into the other module, which is typecast emotional TTS, and it outputs the emotional speech. So that is basically what happens in the pipeline. And next, the requirement elicitation methodology. So over here we used questionnaires, document review, and also we did user testing, user evaluation with users. Uh, so for the surveys, uh, we actually got 7 Sri Lankan Sign Language interpreters to respond to it. And hearing we created 2 questionnaires, one for interpreters and one for hearing impaired, and we got 7 responses for the Sri Lankan Sign Language interpreters questionnaire, and 23 responses for the hearing impaired questionnaire. And for the user testing and user evaluation, we used 2 Sri Lankan Sign Language interpreters and 2 hearing impaired people. The reason for the low respondents is because it's really hard to get in touch with these people, so that's why we have very low number of user evaluation targets. So first, if we And let's talk a little bit about the tech stack that we're using for this project. So uh, for the front end, we are using Flutter. For the mobile application, I have gone with Flutter because it supports both mobile and web devices, web applications. And for the application layer, we have Fast API, which is the backend server where the Python models and Python libraries are used. So the reason for selecting Fast API is because of the flexibility of using Python libraries and the models. And in the processing layer, we have PyTorch, MediaPipe, OpenCV, NumPy. We are also saving the checkpoints and model related data in the drive, so that's much faster. And also we have Typecast API and then the deep phase module. And if we take a look at the parameters that we have used to train the Sri Lankan Sign Language models, we have used actually different models. So these are the parameters used for each of the models. So number of frames is 60, image size is 224 by 224, batch size is 16, epochs trained is 30, patience is 5, and the starting learning rate is 0.001. Sorry, 0.0001. And then these are the models that I have used to train the Sri Lankan Sign Language data on. So I have used 5 different models and CNN. So the highest accuracy and highest performance was gained for the Times Former plus MediaPipe and also the Video MA2 and the MediaPipe per model, which basically the last 2 models. So these performed well and out of all the other models, and combination of MediaPipe with these models are extremely performed better than just the standalone models. And also I got to know that I found out that uh, visual transformer models perform better than the normal CNN models. So these are the results of the Sri Lankan Sign Language model testing. And out of Video MA2 and Timesformer, I selected the Timesformer because it performed slightly better than the Video MA model. And for face emotion results, we have used deep face. So the accuracy for this was around 87, but in low light conditions, it did not perform well. But uh, it was not the main focus of this research, but emotions were identified accurately in good lighting conditions. And next, if we take a look at the summary of the surveys and user testing. So first we'll look at the survey that we handed out to the hearing impaired respondents. So out of the 23, 91% found it difficult to communicate with those unfamiliar with sign language. And all of them basically agreed emotions in speech are important. So this actually fills our research, this actually fills the gap that we identified earlier. And 83% rated a system converting sign language to emotional speech as very useful or somewhat useful. So they would find it very useful to use. And so some of the common areas that they would like to use this would be hospitals, clinics, home, and schools. So these are some of the questions that uh, we included in the surveys, and these are the responses. And moving on to the next questionnaire, which was for Sri Lankan Sign Language interpreters, and all of them confirmed that facial expressions are critical in sign interpretation. So both parties agree that emotion in speech conveying in sign language speech conveying it's somewhat very important because all of them in the target audience have confirmed it. So over 70% were unaware of any current Sri Lankan tools for Sri Lankan sign language to speech. So these are some of the responses, the questions and responses that we have got for the interpreters questionnaire. And next is the user evaluation. So we showed uh, the prototype or the developed application to two interpreters and two hearing impaired people. And so the hearing impaired people, the interpreters first tested the prototype and mentioned that it is overall very good, but cover good for covering emotions, but they suggested that it needs to have full sentence recognition. So that is something that we couldn't cover in I couldn't cover in the research because uh, it was a difficult task to identify emotions in the facial expressions and converting it to speech. So sign level identification is not done in this research, and only word level and sign level identification is done. And the next is the hearing impaired people managed to test it with managed to I managed to test it with hearing impaired people, and they had a good experience with the application, and I think they felt that it would be very helpful for uh, if the application was to be deployed, then I think they would find it very useful. So some of the functional requirements are capturing real-time Sri Lankan Sign Language using mobile camera and detecting facial expressions and translating the gestures and facial emotions into speech. So I have actually covered all the functional requirements that were mentioned in the proposal. And some non-functional requirements would be high accuracy for gesture and emotion recognition. So I achieved around 85% accuracy. So that is uh, greater than what you have mentioned here, and low latency for real-time translation. So translation is uh, done at a reasonable amount of time, so the latency is uh, actually good, and it's compatible with Android, iOS, and also web applications. So next we can move on to the demo. So let me show the application over here. So over here, so I'm currently running my backend server on Google Colab because earlier I actually deployed it on Azure and it didn't go well because it required GPU uh, resources for it to work in a really fast manner. So I moved to Colab because we can use the GPU from Colab and it's much faster on Colab. So if I show you the APIs, so I have three main APIs: emotion detection. So this is for the emotion detection, which is done using deep face, and Sri Lankan Sign Language recognition. So this is done the transformer model that we have trained, and emotional TTS. This is done using the typecast API. So if I show you the Swagger documentation, so this is what it will look like on Swagger. So these are the three APIs. So let me first start with the emotion detection. So I have a video over here called Happy Thank You. So let me show the video first. So this is a video of me signing thank you in a showing happy emotion in my face. So let me play it to you. So the sign that I'm doing is thank you, and I have a happy emotion. Uh, i- as you can see, I'm happy in that video. So happy should be identified as the emotion. So let me uh, open it up, and if I click on execute, so it has correctly identified it as happy. And if I select the other one, which is sad, let me show you the video first. So I'm portraying a sad emotion over here, but the sign language is the same. So if I select this and click on execute, So it has identified the dominant emotion as sad. And moving on to the next one, which is Sri Lankan Sign Language Recognition. So this uses the transformer model. And if I use the same video, let me use happy thank you. So if I execute, it will take some time. So it has identified it as thank you. And next is the emotional TTS. So over here, for example, let me type in today seems to be a good day. And if I type in the emotion as happy and click on execute, it will generate an audio and give me the audio in the response. So it's a downloadable file. If I click on download and if I open up the audio, so this should be in a happy tone.
Today seems to be a good day.
And if I try it with the sad emotion and if I execute it again, so the response is there. If I click on this, so this,
Today seems to be a good day.
so I hope you heard that and it was in a sad tone. So that's how we actually this is the API that we use to send the emotion and the text to generate the emotional speech. So I've showed you the backend, how backend works. So this is what the UI looks like. So I'm running this on web. So this is also installable on uh, a mobile device. So this is what the UI will look like on mobile as well, because this is a cross-platform framework. So let me select the video. So over here, let me select the happy video. So over here, let me select the happy video. And if I click on translate, it's going to take a little bit of time. So the API calls will go to the backend that we just saw, and then it will return the response. So the response would be, so now that it's loaded, it's the text says thank you, and the emotion is happy. And we can also play
Thank
the,
you.
so as you heard, it also gives out the audio. And if you want, you can go back and select another video and then click on translate and it will generate the audio and display the results. So that is how the application works. And let me move back to the slides. That's it for the demo. And if I were to talk about some of the challenges that I faced during uh, doing this research was the real-time performance. So many people have mentioned in the research that real-time performance has been accomplished, but in this project I did initially try to do some real-time processing, but it was a bit difficult with the mobile development and so on. So what I did was, so this is actually a near real-time sorry sorry uh, so this is a near real-time excuse me. So this is a near real-time performing application. So how this works is, when you click on the translate button, the request will go to the backend, and once it's processed, it will return the response, and the response will be shown. So it's a near real-time experience and not exactly real-time. So to come up with that solution, it was a bit challenging to give the near real-time performing experience. And the next challenge is that without proper lighting and control settings, this might not work as expected, because the data set that we are trained on is really small. And for it to work better, we might have to achieve some advanced methods to enhance the product. And another one is the emotion speech alignment. So sometimes if the word is, or if the text or if the text is small, or maybe if it's too complex, sometimes the emotion might not, emotion that we specify might not align with the output. So that is one challenge. But with typecast, it is much better than parlor TTS, but typecast also has some issues like that. And the major challenge and the major limitation of this project is that the data limitation. So for a better output, we might need to train it on more data, and also we might need to custom create a data set, or use some advanced techniques to improve the data set and train the model. And the contribution of this project is that it I believe it's the first Sri Lankan sign language system with emotion integration with expressive speech output. And to conclude this presentation, the major problem is that uh, even though uh, even though that uh, many sign language systems exist, none of them express the emotion that is identified through the face in the speech that is output. And through the research, through the findings and surveys, interviews, user evaluation, we have identified that emotion in the facial expressions while signing is a key factor, and we need to consider that when we develop sign language systems. Uh, and also, hearing impaired people need a system like this because it's really hard for them to communicate during emergency situations. And as future work, we can integrate reminders and also improve the model data set uh, to better identify more sign languages. And also, for this to be a stable and a very well deployed application, we might need to do some scalable deployments and use some cloud services to scale this application very well. And we might need to use some advanced techniques and advanced visual transformers to improve the model, because I have not trained it for many epochs, and training it for more epochs and with uh, uh, monitored learning rate could actually improve the model, and I couldn't do it because of the limited hardware and resources that I have. And for to train it further, it requires much more. It's very costly, so that's the reason I couldn't train it further. So those are some of the improvements that can be done. So with that, we can wind up this presentation. Thank you very much for listening.